would probably actually no.
The Dodgers are.
We got like,
The two and the
is like almost die.
the two is like the whole like it's like
These numbers.
I put it there.
It's also all the other things that I find like. It's just tricky.
Okay, if I can, check your 2022 FRQs.
I said that it doesn't.
Yeah, but- Oh.
Yeah.
Probably right.
Maybe
Yeah.
so.
No, but
I don't know if I said.
Nine points instead of acting.
Yeah.
I
I was pressuring
So
myself.
it's
Yeah.
going to get to the full.
You know,
It's like, yeah, but it's the reasonable rarity, right?
I did practice test and I failed. Like,
No, I said.
it's the long one.
wait, Matt, like, did you take
I
it?
skipped it.
And that one, oh, that one.
We could
Yeah.
use that.
He's almost an
You took it as mine.
That was, yeah, that's.
I'm proud of you.
Yeah, yeah, yeah. It's so, but it's hilarious, you know, shit.
That's hard.
Yeah, but it was.
Yeah.
If this is like when you tomorrow, I feel like I like skip, but I actually was
I like, I know I'm not gonna get a
I
five.
was guys.
I was here.
Oh, Robert.
Oh, it's so fun. I know, isn't the most skill.
Eight changes.
But anyway,
Because,
like,
like, they're,
You're working on your.
I don't know.
yeah,
actually.
the, like, concentration. Oh, right.
You're not be raising.
Yeah, yeah. No, you're, like,
It's weird.
the other day,
And I'm gonna throw up and this means goes.
Maybe an FRQ.
I think, I quit, I actually quit, like, on Sunday, like, how would you guys this stuff?
Right.
Or if I'm on multiple, yeah, I've heard choose. If you get a good.
Working on back and five, yeah, back and five, yeah.
It's on. Like, I. Oh.
Yeah, it's definitely so nice. That's isn't like the like optional file.
It's not.
It's still.
Last day. Sure.
People see the view, but yeah, it's absolutely right. It's the actual, if you don't have like the your side, I think I felt at least prepared for the rotate. Like it's on.
Nothing, I didn't go, because I was sick.
But it's all. I'm like, alright, you're gonna be like, I'm like, the only one that's got pretty good time to say.
Here's what I'm just gonna do. Just gonna take it out tomorrow and try not to.
My research. No, it's.
It's fun like today.
So.
And that's the physics every year for the rest of my life.
I didn't have physics in this.
You got that.
Roll it.
Really good at it. I'm really good at it. Like,
Wait, did you get in the class?
Oh, you good here? Oh, like, I don't know.
I had a dream that I learned about quantum physics and physics, and I was actually counting. But then I woke up.
The actors were always like,
I'm so good at history. I can do the history things out there. Why am I so good at history? God was like, you know what? You can do PhD, you can do a push, but you can't do that.
yeah.
All right, today we're going to work on the 2021 FRQs. I think that's fine. You don't have to simplify it on the object. All right. So I took the time to try to predict what FRQs could show up on your AP exam. So we know we're going to get 3 shared, and we know we're going to get 3 BC specific FRQs. So rated rate out has been kind of like these more recent years. they've been ones that has been showing up on AP exams, and I think that rate in, rate out are problems where, you know, we have rate at which people are entering into the park, rate at which people are leaving the park, how many people are in the park, like those types of problems where kind of extreme value theorem also plays a role in a section. So we'll see some rate in, rate outs over the course of these rest of these FRQs. Particle motion seems to be a popular number 2 in recent years. And then even on the AB side, I think they have their own particle motion problem. Derivative graph, being with a derivative graph, that is a common shared FRQ. And then also Riemann sums, a popular shared FRQ as well. Typically, Riemann sums is where we see NVT show up or IVT show up, and sometimes they stick in related rates as part of. I mean, related rates can exist anywhere. They're just sometimes we typically don't see a related rates dedicated fully related rates problem. It's kind of recent years kind of inserted itself into like one part of the problem. And then miscellaneous BC topics FRQ. Sometimes that can be within the context of an area volume. Sometimes it can be, but sometimes you know, Euler's method and proper integrals can show up. But then again, it's been a few years since Euler has shown up, so maybe it's time for a Euler FRQ. I've given you as many Euler FRQs as I can find. I can't find a whole lot because they don't show up very often. So, but I think we've seen all the Euler FRQs from previous packets that I've given you. So if it shows up, then hopefully we feel prepared for it. I think we're going to see a few in this packet. And then number 6 would also be covered students. So again, 1 and 2 are calculator, and then 3 through 6 will be your non-calculator. Okay, so this is 2021 FRQs. I don't think it's felt as much on the BC side. Maybe a little bit, but on the AB side, I would say that, you know, this was the most difficult FRQs I've seen for the AB students. So we're going to see a little bit of it, but some of, like, number 6 on the AB FRQ was just, you know, really tedious, and I'm surprised that it was so difficult. But then again, you know, if an FRQ years is more difficult than another, then they're going to adjust it on the back end to make it even out. So let's look at number 1 here. This is part B is a little bit strange with this Riemann sums. I'll talk about that in a second. Since density of a particle, bacteria population in a circular petri dish at a distance r centimeters from the center of dish is given by an increasing differentiable function. For f of r, it's measured in milligrams per square centimeters. Values of f of r where selected values are given in the table above. Use data to estimate f prime of 2.25. That's pretty straightforward. That's just slope. But the units of measure feels a little bit strange, but essentially we're just doing this unit divided by this unit. So, and then if we get a positive slope and positive rate of change, then we know that the rate is increasing.
Is increasing by 8 milligrams over centimeters cubed acceptable?
Yes, that's acceptable as well. Yeah. Part B, let me read part B and talk about why it feels different in terms of Riemann sums. So part B says the total mass in milligrams of bacteria featured is given by integral expression, 2 pi integral f of, r f of r. Approximate the value of 2 pi integral from 0 to 4 r f of r using a right-Riemann sum with 4 subintervals indicated by the table. So before you guys write anything down, let me show what we expect from right-Riemann sums, right? This is what we normally would expect. So let me do the easier version of this problem. Let's say the R wasn't there, then it would feel more familiar, right? We just do f of r dr, we just do width times height like we normally would. So we got the width of 1.5, and 1.5, and you pick out the right heights for each of these. So that's how we would do 2 pi integral f of r dr. But what's different is that there is an r in front, so we need to also pick out the r value for that particular height that we're choosing. So this is what's different. It's r f of r, so we're going to have to pick out the 1, the 2, the 2.5, and the 4 that goes along with that right-Riemann sum. So that's a little bit strange. Okay, part C is the approximation found in part B, an overestimate or underestimate, increasing with right-Riemann sum. I think I made a mistake. I think it should be overestimation, right? Okay. Part D, the density is defined by G of R for what value K, just think K as some X value, where the graph is going to be equal to that average value. So we're going to find that average value. And then once we find that average value, then we just got to figure out where is the graph going to actually hit that average value. So we can make the calculator do the work for us. I'm using K. I know K feels awkward, but if you want, you can use X as your variable all the way through, and then just replace X with K since that they're asking you to solve for K.
This is calculator.
This is calculator. Yeah, this is number 1 from 2021.
So if you just left that huge bracketed thing, like that's still a valid answer.
Yes, this is also valid. Even though it's calculated, it's also valid. Yeah. Pages.
I think that's the following red line. So you know, there's no red line. I don't drive. I know.
Skip. So we get that for part D, we get our average value being 9.7857. We want to find out where is my G function equal to 9.857. You can graph both graphs and actually find that intersection. I just prefer to always look for x-intercepts. So what I did was I took my G of x and subtracted the 9.876. I graphed all this and then I looked for my x-intercept. So it's up to you. But ultimately, it's calculator work, so we don't show a ton of steps.
I tried doing that, got 1.01.
Let me see.
Are you agree since we just did?
No, I checked.
So if you look, that cube is only impacting the cosine. It's not impacting the 16 or the 2.
Okay.
So adjust your parentheses. Okay, go to page 16 when you're done. I think an advantage of the BC exam, I know there are some, I know that series is always more difficult. But it's always the most challenging one. But I think I think BC particle motion problem in some ways can be thought of as easier than AB side. So it's nice to have a easy problem that we can kind of rack up our points. So I think for the most part, we like seeing particle motion show up on our BC exam. So they're usually easier and we can earn typically more points there.
So the AV one with one like, distance travel and all that, but just one, like you wouldn't see that at all.
Yeah, typically, I mean, right, yeah, particle motion, like, velocity to acceleration, for one variable, we don't see that on the BC exam, typically, yeah, but that's, you want to just, yeah, there's only a limited, amount of space on the BC exam, so they have to cover the BC topic somehow.
Okay, any questions with number 2? See, I don't know if this overflow error has nothing to do with like. I don't know if it can. I think I should like break it apart, calculate individually. Oh wait, are you doing speed for part A? Yeah. Yeah, I would just do it individually. I don't know if that derivative notation inside the square root will come out the way that we would like it to. I never tried it, so. Like, will they mark off if I don't? You think? I mean, you're not gonna show any of that on the test, right? The most you're gonna show is this. You don't have to write anything, but as long as you can somehow get to this answer, I think that's all the work that you show. Don't put any of the calculator notation on the test.
Wait, so if it's like 0.02 off, it's okay.
Yes, I think they do give some flexibility to that last number here. Sometimes you can either truncate or you can round from the previous value. So, but anything after that it's not gonna matter.
Okay.
Yeah. Okay, number 3, we're moving into non-calculator problems. Part A, so company designing a spinning toy using family of function. We have CX root 4 minus x squared. That C is a positive constant, so that could end up stretching this curve, but essentially this is what the curve is going to look like. The figure shows the first quadrant bounded by the x-axis and the graph y equals CX root 4 minus x squared. Each spinning toy is in the shape of a solid generated when the region is revolved on the x-axis. So we can see that, if we're to rotate this around, we can kind of see the shape of the spinning top kind of take form, right? So that's what we're given. So part A, find the area of the region in the first quadrant bounded by the x-axis of the graph. So we know that we're just doing top minus bottom area of this shaded region of this curved region between the graph and the x-axis. Without a calculator, we're going to have to find that this x-intercept here as one of our bounds. So we can set that to go to 0, solve for x, we get x equals 2. And the rest is just going through our area, doing our integral, and then having to do it by hand because this is a non-calculator. So use substitution required in our steps. But you don't have to clean anything up. As long as you can get to this stage, you can leave your answer in this form, and that will be perfectly acceptable as well.
Issue, I put 12 instead of 1.2. So it's too large.
Oh, no. I think the graders will look at that work and try to give you as much partial credit as possible. Even if the answer is wrong, they're like, oh, wait, you imported the wrong number here, but all your steps is right, your setup is right. They'll still give you partial credit there. It's interesting, grading the AP exam. You think that, oh, if you have a rubric in front of you, that you can just follow the rubric and then just, go down and just grade it.
but every student has a different way of reasoning through a problem. Sometimes you learn things, you're like, oh, wait, I never knew that the problem could be solved this way. So, yeah, really eye-opening, seeing all the different ways that students can solve a problem. And then try to figure out, how does that match the rubric? How many points is that? And that's where all the discussion comes in terms of deciding what point to associate with a student's work.
How do you do second derivative on calculator, like from the original?
I don't know if there's a single operation to do that. I never.
It's on like part A of page 16, it looks like you can just found it straight away.
Well, it gives you velocity. Okay.
Oh, yeah, this is this velocity. This is already x prime, right?
Oh, oh, that is already
It's
velocity.
already velocity, so I should plug it in.
Oh, I didn't see that.
But I did indicate x prime and y prime, but it's already at the mouse level.
I can see for this problem. What you're going to say is the function is constant. It's constantly increasing the constant. It's going to be actually. So you just select because f prime is positive over 1, 2, that is not going to get enough. So that's why we can look at this.
Part B, it is known that y equals c root 4 minus x squared has a derivative, so that's nice. They give you the derivative for that function. For a particular spinning toy, the radius of the largest cross section of circular slice is 1.2 inches. So, we have all these different radius, right, from the axis to the curve region, but the place where the maximum radius is going to occur is going to be 1.2. And the connection is that we know that the maximum radius is going to occur whenever the slope of the curve is equal to 0. So that's going to be the connection point that's going to help us move throughout the rest of the problem. So then part B says, what's the value of C for the spinning toy? So we first have to figure out what the X value is at that point. So we know that our derivative is going to be 0 at the place where the maximum radius is going to occur. Like I said, the numerator of the derivative equal to 0, I can solve for x and I get x equals root 2. And now that I have x equals root 2 and my y value or my radius is 1.2, I can use both those values to go back to my original equation and then solve for c.
That's an AB problem, right?
Yeah, it's an AB problem. Yeah, it is.
And then part C, for another spinning toy, the volume is 2 pi cubic inches. We know this is rotation around the x-axis. We know it's going to be this method, so we set up everything using this method. We know what our volume is, so we just solve everything, and then the leftover C value we can solve. Well, we can end up getting. And again, non-calculator, so we got to do all this by hand here. This is a lot of calculation here. We got to do, normally we could just leave our answer and simplify, but we got to get to volume. Well, we got to get to C value, so we got to find common denominator here. And yeah, it's a little bit that this year's for AB at least is a lot.
There's guaranteed to be a series question.
Guaranteed. Number 6 is always series. Yeah. Everything else, we can kind of guess, but number 6 is always series. Okay, questions with number 3. Okay, on to 4.
Article points and then once you a negative, so there's no charges to the right. That's
Close.
that's the easier reason. Like,
Yeah, that's fine. Because you know that the object is always moving in one direction. It's always never going to. That's the furthest left it's going to be.
yeah, there's no relative max.
There's no relative max, yeah, which is fine. Yep. Okay, let's keep working for another 5 minutes or so. Okay, so tomorrow I'll check the 2021 FRQs. I'll send out a reminder this afternoon. You can come get your phones, and hopefully you guys have picked up packet 6. Again, packet 6, just whenever you finish it, you can turn that in for a quiz grade. All right, complete your phones.